Module 2, Unit 1, using data types and units. In this unit, our objective is to recognize and use different notational systems. These are the naming convention, these are the terminologies when it comes to data, the different types, and the units of measure that you need to be familiar when it comes to IT. And then we will compare and contrast fundamental data types and their characteristics. Marami klaseng data types now when it comes to IT, even the basic ones that we need to be all familiar, because we will deal all of these different kinds of data and units all throughout the entire IT practice or IT world. And we will also discuss how important the data is, its significance, lalo na sa company when it comes to decision making. That's very important. Lalo na sa mga IT professionals when you are talking about IT. Now, starting with decimal notation. When we say decimal notations, these are the names or terms when it comes to number systems. Decimal notation meaning deci, it is a base value of 10 in number system. So it could be any number from 0 to 1, and each column from unit 1 to 10 is worth 10 times than the previous. Those are the things that you remember. For example, a decimal number of 12, it is actually 10 and 2. So how it is being calculated? So if we're going to expand that, so the decimal number 1, 2, 2 is actually a unit number 1, and the succeeding number is always 10 times than the previous. So it's 10, and then from 10 raised to 10 is 100 or times 10, and then from 100 times 10, which is 1000. Now we write down, or the equivalent in the decimal notation in base 10 is 1, which is equivalent to base 10, and then 2 to base 1. So 2 times 1, and then 1 times 10, or 10 times 100 is equal to 10, and then there's nothing on the hundreds, and there's nothing on the thousand. So all of those are 0, of course. So 10 and plus 2, which is actually 12. So basically, we all know, we understand this. 12 is actually a base 10. But for this for the sake of this discussion in notation when it comes to IT, this is how it's being processed and interpreted in the computer system. Now, about binary notation. Even from when we say binary, there are 2 digits, and it is a base value, base 2 place value number system. And binary, it only could be either 0 or 1. That's why it's binary. It only uses 2 numbers, 0 and 1. And this time, each column is worth 2 times than the previous. Sa decimal, diba, 10 times than the previous. Dito naman, 2 times. So, these are easy to represent. And these are the mostly used when it comes to electronics and computer communications. It's all about zeros and ones. When they say 0 and 1s, these are binaries. Now, let's look more into detail when it comes to computation, so when it comes to binary. So for example, here in this illustration, each number is always 2 times worth than the previous. So from 1, 2 times worth than the previous, which is 2, and then 2 times worth than the previous, and it is now 4, and then 2 times 4 than the previous, 8, so on and so forth. 16, 32, which is twice of 16, and 64, and 128. Now we have, let's say we have a binary of 0, 0, 1, 1, 0, 0, 1, 1. So how it is being interpreted or calculated? So 1, which is base 1, 1 times 1, which is 1, and then 2 times 1, which is 2, And then 4, there's now binary 4 0. So 4 times 0, of course, it's 0, and there's no binary digit here. 8 times 0 and 0. And we have a binary 1 at 16, so it's 16 times 1, and then another binary at 32, which is 32 times 1, it is 32, and there's no binary at 64, no binary at 128. You sum all of this and it is equivalent to 51. So ganyan ang binary notation. Now let's talk about hexadecimal. Anyone of you familiar with that? So this time hexa means 16. It is a base 16 place value number system. So this time it could be any digit from 0 to 9, and then instead of 10 it is A, and then 11 B, then 12, 13, 14. Tama ba? So 0 from 0 to 9, and then what's next to 9 is 10, right? 10, 11, 12, 13, 14. It is that's a notational because it's 0 to 15. Now each column is worth 6 times than the previous. And instead of processing more, kasi binary, it presents, for example, it represents a bigger number, it's more binary digits. This time it's just more efficient because only limited characters that you need to use, limited number. So for example here, again, 16 times higher than the previous one, 16, and then times 16 is 256, and times 16 is 4096. So for a hexadecimal number of 4, D, and 12, and 2, sorry. So 1 times 2, it's 2, and then D, which is 13, 16 times 13 is 208, and then 4 times 256, which is 1024, and there's 0 at 1496. So you sum up, you total 1024, 208, and 2, it is equivalent to 1234. 1, 2, 3, 4. Ito ang equivalent ng hexadecimal. When we say hexadecimal of 4D2, and this is the the decimal equivalent, but the computer reads it as 4D2. So that's hexadecimal notation. And then let's talk about bits and bytes. So when it comes to data types and units, it's important to be aware, what do we mean by bits and bytes? So a bit, it's a source of value. It's either binary digit of 1 or 0. When we say bit, it only works with 1 and 0. And then when we say byte, it has 8 bits. A single byte has 8 bits. Ang tawag na doon is byte. Now, we have this also what we call when it comes to representing file sizes and storage sizes, we use a base 10 terminologies. For a kilobyte, it is equivalent to 1000 bytes. Remember, byte is 8 bits actually. So it is represented either 10 raised to 3, and it is also equivalent to 10 times 10 times 10. But this is what's important. You have to remember, kilobyte is 1000 bytes, and 1 megabyte is actually equal 1000 times of kilobyte. 1000 times 1000. Gigabyte, there's 9 digits, diba? So it's actually 1000 times 1000 and 1000 times more. It's a gigabyte. And then you have heard already a terabyte. When we say terabyte, it is also equivalent to 1000 gigabytes. Instead of saying 1000 gigabytes, you say it 1 terabyte. And then instead of 1000 terabyte, we say it 1 petabyte. This is so far the latest to date. So these are the terms when you say storage sizes in terms of bytes, gigabytes, terabytes. Now you know, diba? Now, in some contexts, rarely, even me, I never encountered this, but for your information, when we say base to multiples, it is a kilobyte. It's 1024 bytes. Actually, I even use this 1024 bytes, but for your information and terminology, kilobyte. And then maybe byte. Wow, even me, I'm having trouble to say this. Instead of megabyte, it's maybe byte. 1024 times 1024 bytes. And then GB byte. Maybe that's the reason why it's not. But if you have seen a unit like this, pag ganito nakita nyo, GIB, it's GB byte. It's not for gigabyte, it's only GB. And again, here, GB byte, it's just like gigabyte. Oh my God, it's 1024 times 24 and times 1024 bytes. So, pardon me for those, I mean, kinakain ko yung word na yun. Okay? So, these are the units of measure or units of terminologies when it comes to file and storage sizes. And no, as I've said, it's not always used. I even have forgotten what does it mean, gigabyte. But just now you know, just for your information lang naman. And then we also have this what we call throughput units. When we say throughput units, guys, this is the amount of data, no, coming through at the amount of information in terms of BPS, bits per second. Ito mismo yung traffic, amount of data traffic that is coming through in a communication channel. So when we say kbps, it is also rare. It's like KB per seconds. It's actually 1000 bits per second. This is the speed or transfer rates. These are the words being used. And Mbps, these are the words, no? Kilo, mega, giga, and tera. So Mbps, megabits per seconds, gigabits per seconds, terabits per seconds. The same terminology, base 10. No? These are always the base 10 values. And when it comes to bytes, the same thing. Kaya lang, you see the writing instead of it is written K and capital B and PS, meaning it is kilobytes per seconds, megabytes per seconds, gigabytes per seconds, terabytes per second. So even me, I mean, I almost forget that. So, but I mean, it's on my consciousness, the back of my mind. It's kbps, kilobits per second, or megabytes per second. Those are the things. So now you are now using the same words that every IT or even in the IT world. Now, when it comes to processing speeds, this is the thing that I want you to really understand, because sometimes it's they are interchanged when it comes to speed, the throughput, the data speed, when compared to processing speeds. When we say processing speeds, this is it has to do with the clock, the processor. I think the CPU, performing the operations in a given time cycle. So this time we're using Hertz, no? Hertz, silent H. Hertz. 1 Hertz is actually 1 cycle per second. What do you mean by 1 cycle? A sinusoid, a sinusoid. So that's 1 cycle per second. Okay, let me draw it to you. When we say sinusoid, I mean cycle per second, it's like this. So ito, yan, di ba? Ito yung table. Ito yung time and then the amplitude. So this is actually a sinusoid. This is equivalent to 1 cycle to complete an entire sinusoid, no, from the positive side, then the negative side, and back to 0. So this is a cycle, one complete cycle. So it takes 1 second. So yun ang ibig sabihin niya ng 1 cycle per second. Okay? That's my handwriting. All right. So base 10 on terminology, 1 megahertz is 1 million cycles per second. And then gigahertz is actually 1,000 million cycles per second. Yun ang ganun karami yung cycles nun for every second. And then, as I've said, we have to remember when we say speed and throughput, they are actually different. They are actually different, not often. And in encoding, this is important. And sometimes there are words that you will hear na it's allowing more than 1 bit per cycle. Now, let's data types. Data types there are so many things that being used and processed by the software. And when it comes to number values, there are words that they call integers, which are whole numbers, and then they are what they also called floating point numbers. These are decimal fractions actually, and then booleans, and these are for control and programming, and then sometimes they indicate as true or false, and then represented by 1 for true or 0 for false. Those are boolean values for logic programming actually. And then, meron ding data types na tinatawag characters. You use this when you are using passwords, when you type in, instead of a character from A, like, and then B, C, those are characters, instead of numeric. And then, meron naman what we call strings. Strings is actually a combination or collection of text of characters like DIM, it's a string, no? So, or CHAR, car, it's a string, a collection of text characters, C, H, A, and R. Now, data is represented in different ways when it comes to IT or computer systems. Merong tinatawag na character sets. It's how to represent a particular binary. For example, a binary of 0, 1, 0, and then the rest is 0 with an equivalent decimal value of 32. The character it represents actually is space. So a decimal value of 33 with binary digit of 0100001, it is actually represented by apostrophe. So there are so many binary values here with the corresponding decimal values and character equivalent. Yan ang data, ang tawag dyan is data representation, character sets, data representation. And then there's also an organization that have their own sets of data representation, and ang tawag naman dun is ASCII. ASCII stands for American Standard Code for Information Interchange. So it is actually limited storage and then restricted to basic alphanumerics, and then usually ito ginagamit sa mga communication and data communication. They use ASCII codes as well. And then Unicode, meron din tinatawag na Unicode, flexible naman for representing international alphabets. That's all you need to know about this. But just to let you know, data representation are represented basically in these three. There are so many representation. May mga encoded pa nga, mga encryption. But they use basically these character sets or as character sets in general and ASCII or Unicode. And then data, aside from the types and units, we need to understand the value of its, the significance. And as you should know, data is an asset. Why? Because, for example, data could be your bank account, your resume, or your birth certificate, or at a business level, it is files. Those are files or information confidential na the company has invested. Even us, nag-invest tayo doon sa what's inside the resume, di ba? Or what's on our bank account. So that explains why it's an asset. it has a value actually. Sometimes, or most of the time, we take for granted, and it's very important for the company. And when it comes to an asset, you have to protect it, di ba? We protect our assets. Even the company, especially the companies, they invest for securities. No, like how to secure integrity, and then there are systems to protect it for access and remote control as well. There's so many things. So, and it depends as well how complicate your the security level that you need to invest. That's why they also what they call the return on security investment. Like, this is all about how are you going to justify the amount that you're gonna spend for the type of security control that you apply. Marami klaseng security controls, marami kasing security levels. Like, the more confidential it is, the more or even the control for sharing, that's also involves cost, kasi you're gonna use technologies, you're gonna use hardwares, you're gonna use people. So dapat meron tinatawag na, instead of return of investment, ang tawag dito return on security investment. And then there's also it has to be with risk assessment. I think sa security rin, maintaining the integrity, maintaining the confidentiality, and the availability as well. Those are important when it comes to data security. There's so many things about it, but these are the things in general that you need to be aware. And then when it comes to security controls, there are so many things. And meron din tinatawag na backup of data. That's how we protect data, because when data is being infected, no, that's you need to have a backup. And then meron din tinatawag na access control. When we say access control sa data, these are the things that you allow a person, that you grant permissions. It's either to read, to write, to copy, and so on. So it's either you allow or you put restrictions. Restrictions in a sense, even on usage, like you're only allowed to use or connect to the network to access the data a certain point of time, or during office hours lang. Yun ang usage restrictions, or it only for a particular group of people that you allow. And then there are data aside of plain text, for example, that anyone can read. Meron tinatawag na encryption. When we say encryption, it is like encoded. That it means when you read it, when you saw the data, it means a different thing. Meron ganon. And it's actually a big factor when it comes to IT system, lalo na sa security. And then, meron ding firewalling. This is how you control access in terms of, communication or network or user control to access the data. Those are the things that being considered all the time when it comes to security controls. And then high availability. For example, especially an executive trying to access information, is very important. The executive always have access, and the speed that for regardless of the size of information, na-access niya kagad dyan. And it applies at different levels. It has different kind of availability and priority actually. Now, when it comes to data, we also have this that some of you already know na meron din tinatawag na intellectual property. Hindi lang yan sa mga physical assets or inventions. When it comes to data, yes, meron din copyright. Because especially nowadays, data in IT or information age can be easily copied, no, duplicated. So meron ding copywriting. When we say copyright, di ba, it is signatured by the author, granted to the author, everything. But it's all about the work. Meron ding, it could be an idea, the same idea from other else, but you have something that applied to that idea, that you work on it, that's a copyright. Now, meron naman trademark. When it comes to logo, for example, like Innovare or CompTIA, that is our trademark. No one should be able to use that for other business purposes, or it cannot represent any logo that's been registered by companies. And then when you see this logo, that's their trademark. Sometimes just a symbol. It is a trademark that represents the company. And then there's also when it comes to data, there's also patent. And just to let you know, no, when we say patent, it applies for invention or design that nobody claims na oh kami may gawa nito. No, you actually invented it. You're the one. It's like intellectual property na tinatawag na that's very important, especially in the business world, lalo na sa information age. And when we say patent, dapat it is original and it has applications and unique, distinctive. No, it's not really a variation, or they would say a variation, but they're actually a copy. No, those are the things. Very complicated, and then applied with different and I mean in different jurisdictions. Like in patent is it's been discussed even in masters that may mga limitations. A patent in the Philippines, a patent in US, a patent in UK involves ano na ibig sabihin sometimes oh galing sa Philippines, but actually di ba may mga rumors na ganun, but actually and then it's been released by US now. It's our when it's, pag pinatent na ng US yan, or somebody from US or from UK, it belongs to them. They have the rights when it comes to patent. And then meron ding digital rights management. When we say digital rights management, these are the type of, like for example, subscription or usage or access with limited time, depending on the the fees. Yon. And then meron mga tinatawag din na I'm thinking of the word disclosure agreements, no, in that you don't have to share, copy, something like those are digital rights. These are digital information. Merong rights management din dyan. Now, as been mentioned in the beginning, the significance of data, it is very important when it comes to decision making and creating strategies. Of course, in decision making, it's either, for example, ito ba ang basis natin to move forward? This is also the basis to how are going to make strategies. When you, if especially if the data is recent, so it plays a very crucial role in making decisions. Even us, di ba? So when it comes to production and fulfillment, data are used to analyze, and the same data are are used to as a reference for improvement and productivity. Like for example, in sales and marketing, there's so many applications about data-driven business decisions. Here an example sa sales and marketing, how information is recent when it comes to market. If you have an outdated information about market, that's really affect the sales and marketing activities, di ba? And then the products, whether is it obsolete or latest, those are the things. It comes with an information that tells every sales and marketing executives to make decisions. And meron ding tinatawag na data analytics na some of you already heard of. When we say data analytics, that is the relationship of data to information. It's about how data is being interpreted. If you want me to say it in my own words, so it is actually a record, a storage of information with different combined information and relationship, like a database. There are professionals that do serve as data analytics, di ba? Meron detailed information, meron summarized information. Wow. Alam niyo ba, narinig niyo ba guys when we say information overload, di ba? And then, or it could be an insight that you have a bird's eye view. Now, what this data is all about. And then, you don't have to go into detail and then, unless needed, to make, a quick decision making. And then, di ba, how it's been facilitated for business decisions. Meron tinatawag na data capture and collection. And then data correlation. It's about in relationship, the data. or excuse me, organize this data. And then of course, data, it has to be in a meaningful report, even I would say a presentable format, diba? Now, when it comes to data types and units, we will able to learn in this unit how to recognize and use different notational systems when it comes to data systems and units of measure. And then we were able to compare, diba? And contrast different data types and their characteristics. And then we discussed recently the importance, the significance of data to the company, lalo na sa decision making. So I hope this has been informative to you. See you on the next unit.